Hi, folks, welcome back. So, anecdotally, we all sense that the coding agents can do longer and longer horizon work independently. And so, it was nice to get some more rigorous empirical measurement of that trend. Recently, EPOC AI and Meta collaborated on a new benchmark. They call it mirror code. And this nicely quantifies how coding agents can now, as they say, autonomously re-implement large engineering projects. And if a human engineer would do that, it would have taken them weeks. So let's see what the benchmark is and what exactly they did. So what they're doing is they're trying to re-implement existing software without looking at the original existing code. And what they're giving to the model is simply the original binary, just the binary, not the source code, and a bunch of test cases that the new re-implementation must pass. And they acknowledge that this is kind of a contrived situation because in real world software engineering, this is not the way you build new functionality. But this is a nice contained setup just to measure the model's performance on re-implementing existing software. And what are the things in the benchmark? What are they asking the models to re-implement? So they have a text manipulation program called Choose, a calendar program. GoTree is a program used for bioinformatics simulations, and then PKL is another large library. And as you can see here, Opus 4.6 passed these first three. Whereas with PKL, even with a billion token limit, it didn't quite make it. So how exactly does this work and what is the harness and the setup exactly? So the model is given the original binary, so it can run the binary and observe its outputs. And this lets it figure out what the original program's behavior is in a black box way. And then you have documentation and you have a full test suite. You're giving all this to the model and the harness and asking it to implement the solution in three different languages, C, Python, and Rust. And what they found was that, yes, the models are pretty good at completely re-implementing these programs. So PKL wasn't a complete fail. What they found was it appeared to be still improving with additional inference tokens. So if you scale inference enough, you can do this for larger and larger pieces of functionality. As I say over here, performance scales with inference budget. So the more inference you get it, the more complex functionality you can ask it to re-implement. The other really interesting finding was newer models are getting better at understanding and engineering. Newer models chose more suitable data structures. And this is really interesting because the data structures you choose play a very crucial role in the overall conceptual integrity of your code base. If your data structures are messy, your code will be messy. Now, one thing I wanted to dig deeper on was what exact harness and tools and agentic behavior did they use when they asked the models to re-implement this behavior? And it looks like they've used a very, very simple scaffold. So they have a simple agent scaffold based on a React pattern, and the only tools the agent had were invoking the shell and a text editor tool for reading and writing files. And so I think what they're showing in this benchmark is actually conservative in that if you had given it a much better harness that had access to more tools and crucially that had access to sub-agents, because this harness is being asked to implement this whole thing in one long session. Now they do have some notion of compaction. As I say over here, we use compaction to let trajectories run longer, but it's still one session. And I think they might have been able to get much better performance if they used a better harness like Claude Code or Codex. And they make heavy use of sub-agents, and they do task breakdown such that your main window stays relatively high level. And then they spawn sub-agents to implement individual logical pieces of functionality. But this harness had none of that, which is why I think this was actually handicapping the models. But it's still a conservative measurement. All right, so that was Mirror Code, which is a new benchmark that is showing how the models now are much better at sustaining long horizon work, something that would have taken human engineers weeks of work. And the way they measure it is by re-implementing complex existing pieces of software given just a spec and the original functionality. So this is yet another nice signal of how the models are getting better. You might remember this chart from an older study from METR on the time horizon of tasks, given the progress on models, and how this shows up as almost a neat line on a log linear chart. So the y-axis is on a log scale, so this would be exponential on a linear scale. And that goes up to about a few tens of hours with the latest models. And now they're showing you can sustain it up to weeks of work with the latest models given the right setup. All right, I hope you enjoyed that. If you like content like this, consider subscribing, like the video, leave a comment, and I will see you next time. Thank you.